We have an acceleration vector here, and that describes the acceleration of a particle as a function of time. Find the expression for the velocity and position vectors as a function of time. Assume that x0 equals y0 equals z0 equals 0, and also the object starts at rest, which means that v sub x0 equals v sub y0 equals v sub z0, and that all equals 0. So why did we have to specify those boundary conditions? Let's check right over here. If we just want to integrate along the k-axis, okay, so we're going to integrate a dt, and we're just doing the k-axis. That's the integral of 8 dt, and that just gives us 8t, plus something else, right? Plus a constant, because we don't have any limits on the integral. What is that constant equal to? Well, let's see. Here's our velocity. So velocity at time 0 is 0 in all three directions. And if we substitute 0 in for time, we get 0 plus c. So our constant is 0. So that will apply to all the different integrations we do here. So that kind of makes it simpler. So let's erase this, and then we can go right to our solution, which is in the tab here. And the first thing we'll do is find the velocity vector here. So we integrate the various components along the I, J, K directions, and we come up with this expression here. And here's that AT that we just did when we showed why we can get rid of the constant of integration. So that's the velocity. The next step is to find position. And position is r. And then we have the various different velocities that we're integrating in the x direction, the y, and the z. We carry out all the different math. And here's our answer for position. And of course, this here is our answer for velocity.